So let's start with what's a digital twin. If you're aware of that concept, great. But if not, it's literally a realistic representation of the reality in the digital form, right? So this question could be, is like a BIM model a digital twin? Well, it is part of the digital twin, but not the entire digital twin, right? So digital twin consists of a lot more data sources, and the main purpose of building this digital twin is to unlock valuable insights and enable better decision making, right? That's why the whole industry is driving in this direction, so that we can accelerate different phases of the entire infrastructure asset and make it more optimum and save on a lot of costing around it. So I just wanted to quickly talk about my view of the world when it comes to digital twin. And you can start at different level on digital twin, right? So for an example, you can start at a component, a 3D component. Let's say you have a representation of electronic product. You have a perfect represented 3D model of a phone or all the components in it. Or for an asset, let's say you have your sliding door system as a component. So from that component level, you go to assemblies where multiple components come together, then goes to system, and that forms an asset. But what we are seeing in the industry right now, the industry is not stopping at just one asset level. So for example, you have a substation, which is an asset, right, used in electrical distribution. The industry is going even beyond that, where multiple assets are coming together and they're forming a region or a network level digital twin. So that I'm calling here as a meso level. And then there are even these moonshot or like really ambitious dreams by NVIDIA, where they're trying to create a digital twin at an ecosystem level. So think of entire digital twin of an ocean. That's like mind-boggling, at least to me, but that's at a macro level, right? So with that being said, few further slides will just go into detail. So again, re-emphasizing that point, when you're looking at a micro level or an asset level, you have multiple phases of that asset, right? Digital twin is the central place, or it's like the live representation of everything that's happening with that asset. So if you think of a refinery, it might be going through, even some parts of refinery might be going through different phases, right? Because you have some new development going on a portion of a refinery. So your digital twin, part of it is in concept and planning, part of it could be in construction, part of it could be in operation and maintenance. And the platform that we have built that I'll talk about supports all of these use cases simultaneously. So you're not locking in that data set on a particular use case or particular phase of that asset, but it all has to simultaneously work together. Data from different sources has to, they have to come together simultaneously. Sorry, I misclicked on the slide. And then moving forward on the meso level or on the network level, right? The substation example I was giving you. So you can think of the whole electric distribution network where you have power generation, you have coal plants and wind farms and solar panels, and then you have the distribution system. All of that can be represented through the digital twin, and many utilities providers are doing that because, as you know, there are a lot of safety hazards and whatnot. They're not captured correctly right now. By having this digital representation, by having this live digital representation, they're trying to solve a lot of those use cases. And I think that's where machine learning can be really beneficial, where it's not human monitored, but it's machine monitored, and you get the safety risk highlighted very early on. And then the last part at the macro level, this is, as I was mentioning, really ambitious thing that NVIDIA started. We are partnering with NVIDIA on this. NVIDIA has started their own digital twin concept or platform called Omniverse. And as I was mentioning before, it represents the ecosystem level digital twin. So you have oceans and atmosphere and whatnot, and they are putting in AI layer on top of it to have Earth level simulator. So what will happen to environmental impact if you have 10 new coal plants starting in these 5 states, right? That kind of thing. That's where NVIDIA is going for. So with that being said, a quick introduction of iTwin platform and a couple more slides, and I'll hand it over to Carl. Well, he'll show you the real stuff, the real ML models. So as I was mentioning through these slides, 3D model, the BIM model, or only the map, that's not the digital twin. That is one of the data sources that will go in, right? And as of now, we are seeing reality data, IoT sensors, the enterprise data like coming from SAP and others, geotechnical, geospatial data, the scheduling data, all contributes to the digital twin. And as we evolve on this technology front, and we will potentially have even more data sources going forward, right? They will all come together and represent the digital twin. And we, as a platform, we have obviously built a way to synchronize all that data together. We have our iModel technology behind the scenes as a database which handles the federation and synchronization of all these data sources. And plus, on top of it, we have API layer where you could do a lot more things with your digital twin. And then the objective is you can build your own applications, right? So we will give you these Lego blocks where you don't have to worry about how to visualize a large-scale models that's given to you, and you build your application on top of it. And one of the challenges that I want to highlight to everyone, obviously this is a more academic setting, but in the practical world, having the right data is the biggest challenge in our industry right now. The industry is still ramping up on this digitalization process. It's not as mature as some other technology sides. So the data that we get, it may be coming from 3D models and other. Augmenting that data to make it ML ready is the biggest challenge, practical challenge we are seeing in the industry. So with that being said, on the ML or machine learning, I want to kind of put this digital twin into some staircase perspective, right? So obviously we talked about this micro, meso, and macro level digital twins, but on the machine learning side, personally, I want to see this problem in 3 levels. The level 1, if we can start having machine learning algorithms which assist us in data creation, data alignment, data trustworthiness, right? Because that's our biggest challenge in the industry as of now. That will be the first problem to tackle. The next level is KPI forecasting and prediction, where you want to forecast how much is going to cost, how much potential construction delays are there. Those are a little bit complex use cases, and unless you have a large amount of data to train on, it's really hard to tackle. So that's level 2. Level 3 is where the prescriptive design comes in. And I was looking at the course description. You guys are dabbling into some of that part, obviously, but that to me is level 3, right? Because obviously you can generate a design model, but is it a practical design model? Does it satisfy all the code requirements? Does it satisfy all the project rules, right? To have a good machine learning practical model, it's really kind of that level 3 in my opinion. And plus we will have task automation and whatnot, a complicated workflow automation with level 3. With that being said, I will hand it over to Carl. Carl, you will be sharing the screen, right?
Yes. So basically, I just wanted to start by giving a quick overview of how we approach starting a machine learning project. Because obviously, I manage a machine learning group of data scientists. So everything that we do has to do with machine learning. But when people come to us with opportunities, sometimes it's not clear from the start that machine learning is really what they need. So how can we know that we have an opportunity which is a good machine learning opportunity? So one of the things that you want to look for is, like Ashok was saying, the three levels of machine learning. I really like that. So a place where we do a lot of our projects is with that data quality workflow. So digital tools are clearly picking up, but it's still hard to get your data. A lot of the existing infrastructure was built in the 60s, 70s, 80s. That's a good thing. It means that our infrastructure lasts a long time, but it also means that the data sources for those projects are still old. They happened before the digitization. So a lot of people will have their data just in paper format or unintelligent format when it's digitized. And it's hard to create your digital twin. So we have a lot of projects there where we assist users to create their digital twin. And when we do that, it's not only helpful for management or for operation of existing assets, because there's also a lot of lessons learned from those projects that we can use for the design of new projects. But to do that, we need access to the data, because as I'm sure you've learned in this course, there's many types of machine learning, like supervised learning, unsupervised learning, reinforcement learning. But most of what is concretely happening in the real world right now is supervised learning. So to create those algorithms, you need to have access to data, because that's how the models will learn. They will learn from examples. So the more examples we can get by helping with that digitization of existing data, the easier it is then to build a model on top of it. So when you're thinking of starting a machine learning project in infrastructure, first you need to learn more about what the problem is. If you can find repetitive tasks that need to be done by people, then that's already a good sign that it's probably a good use case for machine learning, because machine learning is really good at automatizing those repetitive process. And then the second most important thing is to really understand what the workflow is for the project. So sometimes you can create an algorithm that will predict something accurately, but it's not necessarily that does not necessarily mean that there's value there. So it's really important to understand, okay, if I was able to predict this, would this really help us in any way? So some of the benefits that we can have is really to simplify some complex tasks, to optimize the results, to help people who are making decisions to make the more appropriate decision and be sure that they can leverage value there. And what we're trying to do, Ben, as a company who's working with many different clients, is to bring together the data from many different organizations and not keep it siloed. So if one client can learn from the errors that are made from another client, then everybody is winning there. So that's something that we really are trying to achieve, but also it means that we need to protect the security of the data, because everyone has their own intellectual property. And if we can do that, then that's where we really open the gates to solving new challenges that are just impossible to solve at the moment and really require machine learning. Just wanted to talk a little bit about how a machine learning project differs from a standard software development project. So the biggest difference is that there's a lot more risk when you're doing machine learning, because when you start something, you don't know how accurate your models are going to be. And it's also really hard to understand how good they need to be for the models to be used. So for example, machine learning, it will never give you 100% accuracy. Maybe you can predict the duration of a project with 80% accuracy, and 20% of the time you're going to be wrong. Is that good enough that people are willing to use it, or do you need more than that? So the first step that we will do when we do a project is we will do a proof of concept stage. So we will just try to build a simple machine learning model. It's not necessarily giving you the full accuracy that you want, but it will give you a sense of, okay, if I put a little bit of work, how good can my model get? And maybe you start from just a baseline model. Maybe it's not even a machine learning model. It can be just computer vision or just some simple algorithms. Like for prediction of the length of a project, you could just use the number of people who are working on the project, for example. And then you start to refine that, you build a small model and you try to evaluate how good it is. And from there, you need to ask yourself, okay, how good does it need to be for people to really start using it? And sometimes it won't be just an automated process. There will be a human in the loop who will verify what the machine learning model is doing, and we'll already start to see some benefit from the prediction from the model. But it's really important to look at this, because machine learning projects can be really long projects, and you want to make sure that if you spend all that effort, at the end, you'll be reaping benefits. So just wanted to go through a small number of examples of projects that we are currently running in production at Bentley. So one of them, we call it Synchro Media Indexing. So it's in our Synchro product. People are uploading pictures every day from their construction project. And one thing that we are doing is we're just running some simple machine learning models on top of it, so that when you upload your pictures, you can search your pictures for stuff that is present in the picture. For example, if I want to search for signs that are on my picture, I can just type this and I will get all the pictures that have sign on them. I can even get bounding boxes around them, like I can get also other classes. So some of the things that we detect with our machine learning models, we can also draw bounding boxes around them. We can count the number of cones, for example, that are, or the number of signs. And some of them are just, okay, this is an outdoor picture. This is, we can see a street on this. And this really helps you see the state of your project. All of the pictures are also, they have a date stamp. They have also a geolocation most of the times if you import the picture as raw format. And it really helps you to use the data that's already available, but to make predictions from them or to extract the information that's really present there. So that's one simple project that we are doing. Another one that we are doing is really for the digital twin creation process. So a lot of people will have old schematic drawings in paper format. This is a P&ID drawing, just represents the process, the pumps, the valves, the pipes that are in a building or in a plant or a factory. And then what we are doing is we are taking those dumb drawings, maybe they have been scanned, and we are running machine learning processes on top of them to detect all of the symbols and associate classes with them. Like here we have the symbol for a pump. We can also look at valves, for example. So here we have check valves, and then all of the text that is written on the drawings, we can also extract it. And for each component, we can assign the text around them so that they have tags around them. So what this allows you to do is that if you have an engineer, for example, that's walking through the plant and sees a leaky valve, and he sees the tag for the valve, it's written on the valve, but he would like to pull out this drawing to know, okay, if I shut down this valve, what's going to happen to my process? Which heat exchanger is going to get affected by this? So before, they would have to run to the office, go through a pile of paper and find the right drawing. But now they can just dynamically query this in their iPod or iPad and pull out the right drawing and even the right section of the drawing to understand, okay, what's being affected here. So we're really taking just paper information and allowing them to create a digital twin that they can use to ask simple questions every day and find the connection between 2D information here or a 3D drawing or reality data or a 1D asset registry, for example. And final project I wanted to show quickly, it's more on the design side. So we have 3D eye models, 3D BIM models, where you have a lot of information and you'd like to build insights from this data. For example, you want to look at everything that's steel, how much steel do I have inside this project? What's the cost of the materials? What's the carbon footprint of creating this project? But to do that, you, like Couchtube was saying earlier, you need to be sure that all your data is properly indexed. And sometimes that's not the case. Like you will look at the model and you will find elements that are misclassified. So what we're doing here is we're running a machine learning model on top of each individual element inside the project. And we're finding elements that are misclassified. So here, this column will show you, okay, what is the correct classification for the model? And here is what the current classification is inside the model. So maybe when the engineer was creating the design, he didn't really look at in what category was placing an object, and sometimes object get put in the wrong place. So if we look, for example, let's take a simple category. Like here we have beams. So this object, which is clearly a concrete beam, it was classified as actually as some glazing. So it was just wrongly put there. And the machine learning model is just telling us, okay, we should be putting this in the concrete category. So if you can make sure that all your data is properly aligned, then you can start to make those calculations of, okay, how much concrete do I need to create this project? And then what's the carbon footprint for this? What's the cost? Am I going to have some delays because I don't have enough concrete available to complete the next project phase? That really opens up the gate to doing a lot of calculation that will save you a lot of money. So that's the demos I wanted to do quickly. And some of the ideas that we have for projects that could be done quickly, working with our infrastructure. Every time we upload an iModel, the logo that you have for your specific iModel is just a basic icon. And one thing that we could probably easily do with the APIs that we have is render the iModels and suggest a specific thumbnail for each model so that we can quickly go through the object. So there would be some machine learning involved in, okay, positioning the camera accurately. Sorry, I lost my slide. Yes, just to position the camera at a place where we can get a clear picture of what the model looks like. And that would help everyone get really quickly through their projects and find the projects that they're really looking for. Yeah, Kaustubh, I will let you talk about some of the data sources that we could provide for students who are interested in working on this.
Yeah, so to facilitate this further, if you're interested in building your project on top of iTwin platform, we have created a Python SDK, which will allow you to take data from multiple models that we have already seeded for you into your Python, PyTorch, or any other Python environment that you want to work on, right? So if you go to next slide, Carl, once you take that data, it will look like this, right? So depending on what you want to extract from that digital twin, you will get different systems or different design elements and different properties on that, right? So what Carl was mentioning on the misclassification, then you can think of, okay, how much volume is misclassified in this particular model, right? You can get that report. And if you go to the next slide, Carl, this is the project where I was mentioning we have like seed data. This seed data is coming from different open sources, industry sources, plus few models that we have built internally. So we are definitely not sharing actual user data with you, but this seed data, we have gone through this, and it's close to the reality. It's not as complex as the reality, but it's close to the reality, right? If you go to the next slide, Carl. And then these are some of the sources that we gathered this data from. So feel free to, even if you're not going to use our platform, feel free to go to these data sources. You will find IFC files and Revit files over there from which you can do data mining for whatever ML project that you want to execute. Kathleen, back to you.
Sorry, can you hear me now?
Yeah.
Yeah.
Much better.
That was really great. Thank you guys so much. Super interesting.
Sure. Yeah, we also enjoyed it.
Okay, thank you guys.
Thank you. Have a good weekend.
Take
Bye.
care.
Thanks. Bye-bye.